Define multiply.
So we're going to wait about 5 minutes to get started, and then we will go ahead. Programming is creative. Yeah. Dude, Twitch ads are the worst, though. Or give feedback of any sort, you can hit us up on our email, utdcsg@gmail.com. We also have a Slack channel, Slack testing, largely talking about the process and procedure and not necessarily hands-on keyboard. This session will be hands-on keyboard, getting started with penetration testing, walking through standard tools like Nmap and Metasploit and how those function. And then lastly, we are in beginning of April hosting a CTF with State Farm. And so sign up isn't available yet, but we're starting to advertise it now. March 5th through 12th is when that will be open, and you'll get more information as it progresses. First question. I thought Canonical Ubuntu was the de facto Linux distro for enterprise. Depends on who you ask. I like Rail better, but Canonical is another industry solution, I guess you would say, that some people do use. So an overview of what we're talking about. I'm going through the basic access control, authentication, authorization, and audit, and then going through some more ephemeral stuff. So configuring services securely, configuring your firewall, basic intrusion detection, and then doing compliance. And so, of course, starting with authentication. PAM. One of the neatest things about Linux that you've likely never touched. Generally, people don't interact with PAM enough or much at all because it's kind of abstracted away from you as a user. You don't really care. But it is the way that you authenticate with the Linux kernel. It's super neat. Very, very different than Windows, where all of that is kind of walled off from you. PAM is 100% configurable from you as a user. This is really cool, but it also has some downsides, of course. If someone mucks with your PAM configuration and changes some things, you can do some pretty malicious things there. But most services that want to authenticate you, whether it's your lock screen, your display manager, SSH, sudo, su, all of those back into PAM for authentication. And so it's going to be all over your system. So an example PAM config, as you can see here, you have 4 different sections: auth, account, password, and session, and they're called PAM stacks. And so for the auth stack, as you can see, we have a handful of modules that are loaded, 5 here, and they have different verbs that describe how they function. And so when I enter the system auth PAM configuration, let's say I'm trying to auth as a user, then I slowly traverse down this stack. And so you start with PAM env, and you can see this has the required directive. That means if this module fails, then the entire stack fails. Similarly with fail delay, and then you have the sufficient directive, which is very different. If you hit a sufficient directive and you pass, then it automatically kicks you out and you have logged in. You finally have requisite, which means that it'll fail, but fail immediately, not go through the entire stack. And then finally required, which once again, if you fail, you fail. And so you have the following directives like I previously showed. You have auth, which verifies a user identity. And so when you're trying to actually auth as your user, you're using the auth directive. The account directive, which allows you to, it checks to see if your account is allowed to do what you think you can do. This is generally not on the level of like sudo configuration, like checking your groups, although it can be. It's a lot of time checking the time of day against your user or checking your UID against a list of UIDs to see if you can do that task. session, which controls steps that happen at the beginning and end of your authenticated session. And so this can be setting an authentication token, removing that token, things like that. And lastly, password, which goes around changing your passwords. So if you've used the passwd utility, is using PAM in the backend to set settings for how you're allowed to change that. And then once again, the controls. Required, if it fails, the entire stack is processed and it kicks you out. Requisite fails immediately. There is different debate on what you should be using required versus requisite, and this is largely due to the fact that an attacker could reasonably gain information about your authentication stack if you're using requisite. And so if you have a check that requires something like your UID to be a certain number, and that's a requisite, I can brute force that check because it'll kick me out sooner than other checks that are happening. Whether that's true or not, I'm not sure. I have not experienced that, but that's the argument that I have seen. Sufficient. If it succeeds with no failures in the stack, then you succeed completely. This is a neat directive that causes a lot of issues if you're writing your PAM config by hand, because you might be trying to set directives below the sufficient line, expecting the user to have to continue authentication, but sufficient kicks them out early. We had that bug over at the Honors College, actually, when we were rolling out a new login solution. And then lastly, optional, which is not a very largely used option, but if it's the only directive set, like it's the only module being used, then optional matters. Otherwise, it does not. So useful modules if you're trying to secure a system. PAM fail delay, as seen here. It sets a delay for in milliseconds. It's milliseconds or microseconds. For how long the user has to wait before they're kicked out. And so if you're trying to stop brute forcing on whatever you're writing the PAM module for, then you would want to use PAM fail delay. PAM Unix actually sets the user authentication from etc password etc shadow. And so if for some reason your configuration is going to be, your PAM configuration for your program needs to auth off that directly, you can use the PAM Unix. PAM succeed if allows you to set constraints on attributes like UID, and it basically just checks the user who's trying to so sorry about the projector. The projector's broken, which is why we don't have the screen rolled down. The PAM succeed if takes in a bunch of attributes of your user and then checks them based against configuration you provide, and then will kick you through or not. And lastly, PAM PW quality. A similar one is PAM cracklib. If you used Ubuntu 14, cracklib is standard there. It sets constraints on passwords. And so if you want passwords to have a specific complexity, like a certain number of special characters, a certain number of uppercase characters for your local users, PAM PW quality is what you would use in your password config. In the what's the .so extension for? It's a so name. You don't actually, when you compile things like PAM fail delay and PAM Unix, you're not actually making an executable file. It's just a library that gets loaded. And so the .so extension is for loadable libraries. So the thing that's actually neat about PAM, like a lot of this configuration doesn't really seem useful because it's like the system configures it for you and you don't really care. But it can be really neat when you're trying to be malicious or checking for people being malicious. And so when you're given a user that has root access to the system, which means that they can change the PAM config, you can add a handful of things that's fairly neat. You can add a malicious module that logs users' passwords. So the PAM libraries do have prior authentication tokens available to them. So it would not be hard for me as a developer to write a PAM module that takes that and either writes it to a file or sends it somewhere remotely. Fairly neat use case, and I don't know how many of y'all have checked your PAM config recently, but I haven't, so the odds of catching that are probably fairly low. Similarly, you can add a malicious module that sets a password backdoor. And so as we talked about the sufficient directive prior, as long as that module were to pass, you would be authenticated. And so you could take any program on the system you want that backs into PAM, put a malicious PAM module into it with sufficient, and set your password for the entire program. Fairly neat. And lastly, fairly easy to DOS people with PAM. If you've ever played with PAM, odds are you've locked yourself out of the system for some reason or another. And so that's generally going to be user error instead of malicious, but it is possible. And as an example of what a malicious PAM backdoor would look like. It's PAMBD. It's a project on GitHub. Really, really neat. And so there's a handful of functions that PAM modules have to implement. But that aside, this is how it works. And so you go through, and it checks the user password against a string set my password. And if it matches your password, regardless of the user, it kicks you through successfully. And so I could drop this in someone's SSH configuration for PAM. And if they have PAM enabled in SSH, I have a backdoor password to any user that can authenticate with SSH. Super, super neat. And on to authorization, which Andrew will cover with sudo.
So, if you use a Linux system, you've most probably used sudo at some point. And basically, most people just use sudo to get to the root user or to get to using a here, I'll get to that. Basically, you're going to be using sudo if you need to get security privileges, which is typically root. But if you don't know, the sudo can actually do a lot more than that. There are a lot of different commands that you can do in sudo, and you can actually use it as a logging system to check and see if someone's added a user or someone has done a sudo command. If you give access to your box to someone that has sudo privileges and you trust them, but you still want to see what they were doing on the box, you can use sudo replay, which is another great functionality. You can configure your sudoers in etc sudoers, and basically what that does is it just lets you determine who has access to sudo and who has access to what kind of sudo command. So a lot of you might have used, I don't know, when I first started using Linux, I used sudo su. Didn't know really what it did. I just thought it let me get into the root directory. Basically what I did, or what it does, is it switches you to a super user. Sudo su is just switching you to whatever user you instantiate. So if you type in sudo su and a username, it'll change it to the username that you type in. Another one is a sudo tac I, which switches you to the user root environment. So instead of dropping you in a sudo shell in whatever environment you're in or whatever directory you're in, it basically just switches you to a shell that's independent of the one you were in previously. The sudo tac s changes you to a sudo shell in your current directory, which basically allows you to, use sudo in the current directory that you're in if you need to do something temporarily. And then sudo tac I tac u allows you to check the capabilities that you have as a user and what you can do. It's really useful if you're on a box that you got user on and you need to see what kind of capabilities you can do for sudo. So another useful tool of sudo, as I said, is sudo replay. Basically what sudo replay does is it allows you to check what someone's done in the sudo, And to enable it, you just have to type in viz sudo, which types in vi, and edit your sudo config and type in these at the bottom. I believe that they are commented already by default, and you just can uncomment them. But if you don't want to find them, you can just type these at the bottom. Basically what it's doing is it's setting the default log output, it's setting where it will output to and what it'll be checking for. And then you can use sudo replay tac L to list your sudo commands, and the tac L can be of a user or of a certain file that you want to output. You can also, you can do more with this. You can also replay it in real time, which means that instead of it running based off of what you just listing all of the commands it did, you can see how long they took and what the time intervals were between, and you can speed this up too. So Nick will be doing get UID.
And so with setuid and setgid binaries, you have The ability to